Good afternoon. My name is George Matos, Senior Product Manager here at NVIDIA. Today we're going to be talking about NVIDIA Omniverse Enterprise and the overall Omniverse platform. It's a new era of collaboration and simulation. So today I'm going to take you through some slides that kind of talk about all this. I have some videos explaining kind of how this works. We show some kind of live pieces of people working together and some things kind of outside of kind of just the normal AEC industry. So as I go through this, you're going to kind of see, again, a couple videos, and we'll try to step through this quickly and then have time for Q&A at the end. And quickly, I just have to kind of show this statement talking about because the platform is in various stages, basically, we can't, the roadmap doesn't constitute a commitment, promise, or legal obligation and is subject to change. So with that, the next thing I'm going to do is a quick infographic video trying to explain what Omniverse is.
As an animator, designer, or engineer, you can bring the power of collaboration between applications and people to your workflow with NVIDIA Omniverse. Before Omniverse, working on a project using multiple applications required exporting and importing from one format to another, often causing creators to lose information and compatibility along the way. And adding more people into a workflow was a nightmare of updates and file merges. The Omniverse platform enables true real-time collaboration for individuals and teams working between multiple apps and working across geographies. Omniverse brings the ability to seamlessly sync file changes between the creative tools you know and love, maintaining their integrity throughout your pipeline. Whether working alone or together, Omniverse creates an infinite number of connections, from app to app, person to person, or office to office. Get Omniverse now and experience the future of collaboration for yourself.
Okay, and today, traditional 3D workflows are very complex, right? They kind of require a broad range of skills, and it's, with that broad range of skills, we're also very global, right? So we have people in many different locations throughout the world. As it shows here in the middle, many vendors, many tools, and kind of, as it states, the tedious import and export process, right, of going from one tool to another. And then also the complexity of 3D workflows, right? So demand for kind of compute heavy technologies, as it says here, and that goes along with just the complexity of the model, right, and transferring that data. And so in today's kind of world, right, we basically see 3D workflows are essential for all industries, as it shows here, right? So whether it's our industry, AEC, media and entertainment and game development, product design and manufacturing, scientific visualization, robotics, or autonomous vehicles, we're all having the same problem of these large complex workflows. And in some regards, we're also starting to kind of cross industries between one another. And so new challenges that came up, right? Part of those new challenges happened, I think, with the pandemic. I think some companies were a little bit more prepared than others, but with that, it's kind of the new normal, right? How do these complex data sets and these complex teams work when being remote? And so, we're trying to address the new normal, if you will, with, flexible kind of access to high performance compute, right? And what is that? Could be a physical machine, could be a virtual machine, or any sort of hybrid model between there. Again, 3D data sets are extremely large. How is it easy to copy these massive, buildings, cities, worlds, as we call them, right? To be able to quickly iterate on them and keep expanding them. And then chasing single source of truth, right? So with that, it's kind of a widespread file imparity. Inefficient copying, as it says, sending files back and forth are disruptive bottlenecks, right? As you do something, you don't want to have to save the entire file back, or a massive amount of a portion of that, city, building, etc. And so with that, here's a kind of layout of Omniverse, right? So if we think of this in a very basic manner, on the left we have different users with different skill sets. So we can think of somebody here on the top as somebody that knows Rhino, somebody that knows Grasshopper, and then maybe in the middle somebody that knows Revit. That last person could be another Rhino Grasshopper user, Revit user, or a 3ds Max or Unreal user. And so they're taking kind of their single source of truth and kind of exporting, pushing into the Omniverse world. Okay. And so they're continuing to use kind of the software that they know and that they're best at, right? It's their expertise, if you will. And so that data then funnels into Omniverse. But when it's inside of Omniverse, now we can actually talk to one another. And so key parts of that below that kind of make up what Omniverse is USD, which we'll get into, physics, materials, path tracing, and AI to do things. And then, how do we look at the world, if you will, the simulated world, as I like to call it, right? So there's different ways you could look at the simulated world. You can look at it on a screen like a monitor. You could look at it on a tablet. You could do AR, and you could do VR. So there's a lot of different ways to consume this. And so if we look a little bit more as to what, how Omniverse is made up, this is kind of the basic schematic of the Omniverse platform, right? So NVIDIA Omniverse Enterprise is kind of this end-to-end collaboration simulation platform that transforms complex design workflows for organizations of any scale, with real-time interoperability across applications. Infinite iterations come at no opportunity costs, right? So if we think of this again, on the left side, this is kind of our ingest of various sources of truth. And then we come in and we have things that make up kind of Omniverse. In the middle here, we're saying nucleus, which I'll go over in a minute. We have our storage, right, where we store everything. Then we have these microservices that you can do different things inside. And then we have some apps on the right side that we've built and others can build upon. And then again, how do you want to view it, right? We say workstation at the top, but that could be a laptop, that could be a virtual workstation, and then we go down the list, VR, AR, web browser. And so what is the platform as a whole? The easiest way to think of this is there's these 5 components that are made up of the platform. So on the left side, we start with nucleus. Nucleus is the brains of the operation. This is the thing that's constantly communicating between the various sources of truth, software like Revit, Rhino, 3ds Max, simulation software, etc. And then the next one is Connect. So this is our Connect library. Basically, this allows us to take something, for instance, Revit, and we export kind of to USD. But with that, we do a couple things. So you can take an entire scene, you can do something we call as a prop, and you can also do something that we call live sync. So that allows a live connection from Revit to Nucleus, and it allows us to see changes that are kind of happening. So you see the source of truth data being updated in the simulated world, if you will. And in the middle, we have Kit. So this is our toolkit. This is what we kind of build upon, and you can make your own app. So I'll go over in a little bit a couple apps that we have made for you to use kind of out of the box, but you could make your own. And then we have simulation. So this is part of our PhysX that allows blast and flow. And this allows you, as it shows kind of robotics on the side, to help simulate things, right? And that simulation could be an autonomous car, could be robot. It also helps with taking simulation data in and actually seeing that simulation data in real time with the building. And then on the right, we have our RTX renderer. And the RTX renderer is an advanced multi-GPU enabled renderer based on NVIDIA RTX that supports both real-time ray tracing and referenced path tracing. And so lastly, the things on the left, Nucleus, can live on a local machine, but the idea is in an enterprise environment, it would live on a blade server, right? So it's sitting on a thin blade server and connected to your persistent storage. It could live up in the cloud. You could have multiple Nucleus servers, but that does not require a GPU. That's just the brains talking, right, to everything. And then we have our Connect, which is just the connectors in a sense. And again, that doesn't require a GPU. The three things on the right, that is what requires a GPU, and it requires an RTX GPU. And the reason for that is it needs the tensor cores and the ray tracing cores. And then the underlying foundation, a couple slides up that we showed, it talked about USD. So USD is the underlying foundation for Omniverse. It stands for Universal Scene Description. It's, as it says here, HTML of 3D virtual worlds. A good way to kind of think about it is, think of HTML like in Google Docs, where Google Docs came out and you could collaborate with people in real time. That's what USD is for this, right? And so it was developed by Pixar many years ago. They developed it similarly in-house because they were having problems, and then they realized that USD could be beneficial to the world. And so there's a lot of things that USD can do. Biggest one is it takes any form of data, whether it's geometric or metadata. And again, it originated kind of in media entertainment, but it is becoming standard across multiple industries. And then quickly kind of connecting to Omniverse Enterprise. So we've got a couple different connectors. So at the top, we have bidirectional connectors, Unreal Engine, Autodesk 3ds Max, and Autodesk Maya. In the middle here, we've got unidirectional connectors. So Rhino, Grasshopper, Autodesk Revit, and SketchUp. And right now, we don't have that as a bidirectional because, again, as a source of truth, right, for instance, Revit construction documents, I don't want to be moving a wall somewhere else and then have it automatically update back, inside of Revit, right? Not without some sort of checks and balances. So for now, they're unidirectional. And then at the bottom, we have kind of import and export options. We can import various types of data and it'll auto convert to USD. So currently we have Alembic, E57, IGES, LXO, MD5, STEP, FBX, GLB, GLTF, OBJ, USDZ, and USD, obviously, right? And then we have kind of the export on the bottom as well. Now, for those that don't know how kind of widely used USD is, anybody that has an iOS device, all your emojis are built on a form of USD with USDZ. And then here's a quick look at kind of Omniverse apps. So in the green, these are for Omniverse Enterprise, and on the right, it's kind of what we call our open beta. So they're not fully fledged, ready for an enterprise standpoint, but you can use them to test things as they're being developed. So on the left, we have Omniverse Create here. It's kind of, as it says, our advanced world building simulation. So this is where you can go build extensions for things that maybe aren't in there that you want to connect, where you can go create simulations with various, different things. You do your material editing, you can do basic modeling, but really you're pulling that model data in from, again, the source of truth, right? And then Omniverse View, as it kind of says there at the very end, review, think of this as more of a review tool, right? So it's limited as to what you can do. It's meant to kind of pull up and for kind of a non-technical person to be able to look, walk around, and do things. And then at the bottom, we have a bunch of other applications, Omniverse Machinima, Audio to Face, Omniverse Kalen, our Isaac Sim, and then our Drive Sim. So again, these are things that are still being developed, and you can get those from the beta side. And then quickly, a difference between the two is that the beta is kind of out there, and the support mechanism that you get is through the community forums, where the enterprise model that was announced last GTC is a paid piece that's coming, and that will give you enterprise support among other things as well. And then lastly here, power, large scale simulation. So the way we think about things here is if we look at all of this, anything that's built will be visualized, right? Anything that moves will be autonomous, and anything autonomous will be simulated. And then kind of Omniverse for AEC quickly. So if we think about this and what we think where we're at today with Omniverse for AEC, this is kind of what we thought about when we kind of built where we're at today for the AEC side, right? So initial concept design, competition and bid submissions, client presentation, global collaboration, and speedy design reviews. That's kind of where we're at today. Things will keep getting expanded upon, right, as the platform grows. Now you can do other parts of it in various parts throughout the piece, but we don't have everything, right? So as a list of inputs we have from various softwares, you can see some more being expanded upon by our partners themselves. So that list keeps growing, which then therefore we keep being able to do more. Now I'm going to show a video quickly of a video that we built, kind of a asset that will be out there within Omniverse that you can do yourself and look at. But it was trying to show an architectural workflow between mostly 3 people, and then I come in as like there's a 4th person that's like a project manager. But the idea here is to try to replicate a workflow with architectural assets.
In architecture, collaboration and communication of design intent rank high among the many challenges project teams face. These become even more difficult when team members are remotely located and geographically dispersed. The need to translate and aggregate data from different software tools, datasets, and other project contributors complicates matters and slows down the design process. Today, there's a growing demand for more efficient team collaboration during design, faster iteration on high-fidelity rendering, and the expectation of accurate simulation and photorealism. NVIDIA Omniverse Enterprise is a game-changing reference platform for collaboration and real-time, true-to-reality simulation. Widespread project teams can now maximize productivity, enhance communication, and boost innovation while collaborating on the same 3D model from anywhere. The Omniverse Enterprise platform contains powerful components for maximum flexibility and scalability and can be deployed on a local machine, on-premises, or in the cloud. Omniverse Nucleus, the data exchange and collaboration engine, is at the core of the platform. Nucleus allows users to store, share, and collaborate on project data. In this example, a single designer working on their local RTX-enabled workstation is enhancing their day-to-day workflow by using Omniverse to work between 2 design applications. Here we can see Autodesk Revit on the right and Omniverse Create on the left. Adjustments and design decisions are being made in Revit and live updating in Omniverse. This allows for high-fidelity viewing of the Revit data as the changes happen. In addition, with the powerful suite of Omniverse connectors, users are able to continue to work in their favorite industry software applications. Combined, Omniverse Nucleus and connectors provide the unique ability to collaborate live across multiple applications. In this example, Rhino Grasshopper is contributing full fidelity data, an ornate chandelier, to a Revit model, and the designer can see the combined datasets in a shared virtual scene viewed in Omniverse. This allows for an interactive, photorealistic workflow between your parametric design model and your fully embedded design environment. Collaborative design lets your teams make better decisions faster. Multiple users, creating with their preferred industry design applications from various geographical locations, all in real time, is all made possible with Omniverse Enterprise. In this example, 3 designers and a project manager are simultaneously collaborating on a shared scene with Omniverse Create. With Alice in New York, Dave in Colorado, and Jay in California, a collaborative design environment is allowing for rapid creation, iteration, and visualization of a building interior. Live sync collaboration amongst the 3 designers provides the ability to rapidly populate the space with props while making any necessary adjustments to positioning, materials, and overall visual style. Omniverse provides real-world physics and advanced simulation in real time via core NVIDIA technologies such as PhysX and Flow. Here, the positioning and placement of plates and decorative fruit is intuitive, with objects simply obeying the laws of physics. Multiple designers, using different software applications of their choosing, are able to collaborate on a single scene and really explore possibilities in context, modify CAD files, insert infinite polygons worth of data, and interactively change the time of day. All of this while never having to do a single test render. Omniverse RTX Renderer is an advanced, multi-GPU renderer based on NVIDIA RTX that powers both real-time ray tracing and reference path tracing. Multiple users working together on a scene are able to view real-time ray trace scenes using the Omniverse RTX renderer. Material and live sync geometry changes, as well as lighting studies, all contribute to a photorealistic collaborative design review and visualization. The Omniverse RTX Path Trace renderer produces stunning, high-fidelity visuals of large, complex datasets in seconds. Like everything else in Omniverse, scalability to multiple GPUs increases the power, performance, and overall creative possibilities. Furthermore, rapidly producing stunning visuals in Omniverse lends itself to a performant presentation tool. Accelerate time to production, increase the value of existing infrastructure, and eliminate the trade-off between productivity and innovation. Let NVIDIA Omniverse Enterprise open your design world with collaboration and real-time, true-to-reality simulation.
And last, just quickly on that scene that you just saw, one thing I wanted to bring up is kind of the size of that scene. So this is about 20 gigs of kind of memory that would be needed in the GPU. It's got 1.5 billion polygons, 2,032 lights for the night scene as you're seeing here, and it has over 12,000 MDL material textures. So that gives you a size, even though we're showing housing in a park, it shows kind of the complexity of the scene. Now I want to kind of show one last video before we wrap up, and this is actually for those that haven't seen it. We did some things with Jensen's Kitchen and what we call virtual Jensen, and so there's a kind of a behind the scenes stage that talks about all this. And I wanted to play that because there's some photogrammetry and other things that relate to what we do within the industry. And so let's watch that video now.
We're doing this awfully early.
This is the first GTC that will run across the world's time zone sessions in Chinese. The software written by AI is very different than that written by a human.
The beige hue on the waters of the loch impressed all, including the French Queen.
Amazing increase in system and memory bandwidth. Today, we're introducing a new kind of computer. What I'm about to show you brings together the latest GPU accelerated computing, Mellanox high performance networking, Today, we're introducing a new kind of computer. The basic building block of the modern data center. What I'm about to show you brings together the latest GPU accelerated computing, Mellanox high performance networking, and something brand new. The final piece of the puzzle.
And I just wanted to close out by saying to find out more information about Omniverse Enterprise for AEC, if you go to the link on the site here, www.nvidia.com/ov-AEC. Hopefully everyone was able to learn a little something. There's a lot more to talk about, but feel free to contact me with any more questions. Thank you very much.
So hopefully, yes, we are joined by George. Thank you for dialing in, George, to join us. Take some questions from the audience. Does anybody have any questions for George?
Afternoon, everybody.
Well, I'll start with a question then. George, the focus on Omniverse from this presentation, particularly with the branding, is very much enterprise. How applicable is Omniverse to smaller architectural practices, say 5-person teams?
It's a great question. So we have two flavors of Omniverse. There's kind of Omniverse for individuals, so it's really for kind of 1 to 2 people, if you will. And that, that 5-person, it's kind of we're trying to figure what that is exactly, right? And then the idea is for enterprises really kind of 5 and over. And the reason for that is it has to do with the kind of the collaboration and the real-time piece that you're going to need. That's where there's a little bit of a differentiation. But kind of the way we suggest everybody start is go try the open beta. It's free. That's kind of the individual one, and learn from that, right? If you see that you're getting to a point where I want to collaborate with more people, reach out to us and we can talk about the enterprise side of things, basically.
Okay, thank you. Anyone questions? Sure. Let me just come over.
Sorry, this might have been obvious, but do we 100% need an RTX card to be able to use Omniverse at the moment?
So yeah, so if you remember, it's another good question. So if I go back to those kind of 5 columns, right, or the 5 components, the nucleus piece, the thing that actually interacts with everything that's talking to the various apps, that doesn't need a GPU, right? That's just the kind of a blade server that's communicating. So it's processing, RAM, storage. Then the connectors you don't need, right? So I could be on a laptop, that has an Intel hybrid chip, for instance, right? That I'm pushing USD data out to kind of look at the simulated world, as I like to call it. That's what requires an RTX card. So you have to have the RTX card for 2 reasons. It's for the ray tracing, and then the other part is when we're talking about anything that is kind of simulated. So, when you're talking physics, so AI, machine learning, or deep learning, that needs the other part of the RTX, which is the tensor cores. So to kind of view the simulated world, that's where you need the RTX piece.
Thank you. Any more questions? No? Okay. Thanks very much, George, for joining us.
Yeah. Thank you, everybody.